Dear friend, as a continuation of the session 1, and we have to see the remaining infinite series. The remaining infinite series tan x. The infinite series of tan x, first term x, second term x cube by 3, and third term 2 by 15 x power 5, plus keep going. Just remember 3 terms. Only 3 term enough. When you apply the infinite series, only first term alone get cancelled. From the remaining term, we can get the answer. X plus odd term alone. X cube, x power 5. First coefficient 1, then 1 by 3, then 2 by 15. Just remember 1 by 3, 2 by 15. This is infinite series form of tan x. Sometime we can use x cot x. X cot x 1 minus x square by 3 minus x power 4 by 45 plus etc. Then secant x 1 plus x square by 2 plus 5 by 24 x power 4, then x cosecant x 1 plus x square by 6 plus 7 by 360 x power 4. Okay, then how to derive all these infinite series? You will have very big question how to derive the infinite series, and based on Maclaurin series we have to use Maclaurin series. Use Maclaurin series. What is Maclaurin series? F of x, any function, any real function. First term f of 0 plus f dash of 0 in the x by 1 factorial plus f double dash of 0 x square by 2 factorial plus f triple dash of 0 x cube by 3 factorial. Keep going. If we take f of x equal to tan x or x cot x or secant x, whatever you want, the infinite series of that particular function, take that function, find the first derivative, second derivative, third derivative up to fifth derivative, then find all the fifth derivative taking x equal to 0, substitute in the Maclaurin series, you will be getting the listed infinite series for any real function, Okay, let us continue. uh, Then inverse trigonometry function, sine inverse. Sine inverse x plus 1 by 2 dx cube by 3 and plus 1 by 2 into 1, 2, 3, 4, 3 by 4 dx power 5 by 5, 1 by 2, 3 by 4, 5 by 6, x power 7 by 7. Keep going. So this is infinite series form of sine inverse x. Sine inverse x. Then tan inverse x. Tan inverse x minus x cube by 3 plus x power 5 by 5 minus x power 7 by 7. Keep going. This is tan inverse. And one more very important infinite series, 1 plus x whole power 1 by x. The infinite series of this one, e power 1 minus x by 2 and plus 11 x square by 24. Keep going. The exponent of e itself an infinite series. So 1 plus x whole power 1 by x, the whole thing. So why should we give more importance to the last infinite series 1 plus x whole power 1 by x? It's a fundamental theorem. If we take limit x approaches 0, 1 plus x whole power 1 by x is equal to e power, take limit is a composite function, x approaches 0. If you apply the limit for entire infinite series, 1 minus x by 2 plus 11 by 24 x square, keep going, and e alone will come. This is a derivation of the result, fundamental result. So limit x approaches 0, 1 plus x whole power 1 by x is always e, or the limit x approaches infinity, the x and 1 by x should be interchanged. Then we will be getting a similar type of result. The same result, limit x approaches 0. The previous result we can interchange x and 1 by x. So x and 1 by x means instead of 0, and this is infinity. Infinity 1 plus 1 by x whole power x is also e. Make note of it. There are two different results but the same answer. X approaches infinity means the bottom 1 plus 1 by x. The exponent should be x. X approaches 0 means the bottom 1 plus x whole power 1 by x. Combining these two, what is the general result? In general, limit x approaches a, 1 plus f of x whole power g of x is one of the indeterminate form. One of the indeterminate form, this limit equal to e power limit x approaches a f of x into g of x is the most important formula for joint entrance examination and point of view, and copy it. So dear student, this type of question, limit x approaches infinity, 2x square minus 5x plus 1 divided by x square minus x plus 2 is known as limit of infinity. Limit of infinity. What's the type? A limit of infinity. Then what is a shortcut? We have to learn shortcut also for many things. So the success in mathematics and based on the strength of shortcut. And we have to apply, we have to learn all types of shortcuts for every chapter. So limit x approaches infinity, 2x square minus 5x plus 1, x square minus x plus 2. If we find a direct limit taking x infinity, indeterminate form will come. Infinity divided by infinity. So infinity divided by infinity is an indeterminate form. So inconclusive step. Then we can apply a L'Hopital rule. We can apply L'Hopital rule. Okay. This is one method. A limited infinity means shortcut. The numerator one polynomial, denominator another polynomial means take only the coefficient of the highest degree term of the polynomials in the numerator as well as denominator. What is the coefficient of x square from the numerator? 2. Coefficient x square from the denominator 1. So this is the answer. That's all. So if you come across this kind of question and apply this shortcut, what is the regular method? And limit x approaches infinity, divide every term by the highest degree term x square. So 2 minus 5 by x plus 1 by x square. Denominator also 1 minus 1 by x plus 2 by x square. Now taking limit and 2 minus 0 plus 0, 1 minus 0 plus 0. So final answer 2. Okay, copy it. And the next question, dear student, limit n approaches infinity, 1 by 1 minus n square, the last term n by 1 minus n square. So limit n approaches infinity and 1 by 1 minus n square and 2 by 1 minus n square and last term n by 1 minus n square. Okay. So limit n approaches infinity, the denominator fixed, that is 1 minus n square. The numerator 1 plus 2 plus 3 up to n. Up to n. So we are very much familiar with special sequences. Okay. So 1 plus 2 plus 3 up to n, summation n into n plus 1 by 2, n into n plus 1 by 2 into 1 minus n square. Correct? This also the type limits of infinity. After expansion, the numerator n square plus n. A denominator minus 2n square plus 2. Applying the shortcut, what is the answer? And minus 1 by 2 is the answer. Take coefficient of n square from the numerator. Take coefficient of n square from the denominator. Minus 1 by 2. So this is the final answer. The next example, the numerator 1 square plus 2 square plus 3 square up to n square. The denominator n cube. The denominator n cube. If we take the limit straight away, infinity by infinity will come. What is the straight substituted value? Infinity by infinity. This is indeterminate form. Indeterminate form. So to avoid indeterminate form, what to do? The limit should be real number. Limit n approaches infinity. 1 square plus 2 square up to n square by n cube. So limit n approaches infinity. 1 square to n square, special sequence formula, n into n plus 1 into 2n plus 1 by 6. Applying shortcut formula, what is coefficient of n cube from the numerator? 2. What is coefficient of n cube from the denominator? 6. Therefore, final answer L equal to 1 by 3. So, this is the answer. The next example, limit n approaches infinity. There are two factors in the numerator, 1 to n, one special sequence, that is summation of n. The other one, 1 cube plus 2 cube up to n cube, and sum of cube of first n natural numbers. It is summation of n cube. The denominator is summation of n square, the whole square. So if you take the n infinity, here also we can end up with a similar result, infinity by infinity, indeterminate form. So to avoid indeterminate form, I'll do straight away a limit L equal to limit n approaches infinity, 1 plus 2 plus 3 up to n into n plus 1 by 2. The other one, n into n plus 1 by 2 the whole square. The denominator n into n plus 1 into 2n plus 1 by 6 the whole square. Okay, and we have to simplify all this. You have to simplify all this. On simplification, limit n approaches infinity is 36 and 4 into 2, 8. Okay, 36 by 8 for the constant, 36 by 6 square 36, 2 square 4, 4 into 2, 8. Other than constant factor, n into or n into n plus 1 means n square plus n whole cube, or n into n plus 1 whole cube. divided by n square, then n plus 1 the whole square, 2n plus 1 the whole square. Okay, then limit n approaches infinity, 36 by 8 lowest form and 18 by 4 and 2, 9. So finally 9 by 2. This is 9 by 2. Okay. The remaining part, we can take n cube and n plus 1 whole cube mean, and n power n cube, n plus 1 whole cube, and n square, n plus 1 whole square into 2n plus 1 whole square. Now L equal to limit n approaches infinity, 9 by 2, between n square and n cube cancel, n on all left, n, n plus 1 whole square, n plus 1 whole cube, n plus 1 is left. The denominator only 2n plus 1 the whole square, correct? So in the expansion we can take highest degree, n into n square, because n approaches infinity, n into n square, denominator 4n square, the one of the expanded term. Applying shortcut, what will be the answer? 9 by 2, here 1, here 4. So 9 by 2 into 1 by 4. Therefore, L, the limit of the given question, 9 by 8. So this is the final answer. So dear student, this is a little different type of question. Limit n approaches infinity. Why this is a different type of question? Here the special sequence, infinite series or uh, partial sum is not given. So we have to apply rationalization. We have to apply rationalization. At the same time, limit of infinity type. Dear student, if you apply limit straight away for x infinity under square root infinity, root of infinity, infinity varo. Another infinity. Remember, difference are two infinity terms in determinant form, not zero. Indeterminate form.
Because they are different infinities.
So infinity minus infinity indeterminate form, and infinity plus infinity is not indeterminate form. That is infinity. Very important. Infinity plus infinity again infinity. This is not indeterminate form. Make note of it. But difference are to infinity, always indeterminate form. Now, what to do? Let us take L is the limit. Limit x approaches infinity, square root of x square plus x plus 1 minus x. The straight away value infinity minus infinity. To avoid indeterminate form, we can apply rationalization. After applying rationalization, and x square plus x plus 1 minus x square, the denominator root of x square plus x plus 1 plus x. Then limit x approaches infinity, x square cancel, x plus 1 alone left, and root of x square plus x plus 1 plus x. Now what to do? Because of infinity, and we can divide every term by x. Divide every term by x. Because the degree of numerator 1, degree of denominator 1, that's why every term should be divided by x. Not simply. The numerator 1 plus 1 by x, correct? The denominator within the square root 1 plus 1 by x plus 1 by x square, then 1. Now taking limit, all 1 by x or 1 by x square term becomes 0. Final answer from the numerator 1, from the denominator root of 1 plus root of 1, 2. Dear student, 1 by 2 is the final answer. 1 by 2 is the final answer. Thank you.